So we are still on revision questions about complex numbers. So up to now we are on number 13. Number 13 is saying, find all cube roots of the complex number. We have w which is equal to -1 plus I. Review your answer in polar form and the trigonometric form. So we are going to answer number 13. So that's number 13. You can find it on number 18b, lab 2011. Lab 2011. Okay, now we have w which is equal to -1 plus I, and we're going to find the cube roots of that complex number. Remember the nth root of complex number, if you remember very well, the nth root of complex number, the way we find it, we use the formula which is zk equal to the nth root of r into bracket cos angle over n plus 2k pi over n plus I sine angle over n plus 2k pi over n. So where k is an integer, k is from 0, 1, 2, up to n minus 1. N is the number of those roots that they are asking. For example, they are asking to find all cube roots of that one. It means that our n is 3. If our n is 3, our k will be equal to 0, 1, 2, because 3 minus 1 is 2. So, okay, we need to find the modulus of this z and argument of that, the modulus of this w and the argument of this w. So, the modulus of w is the square root of, which is r, we call it r, square root of -1 squared plus 1 squared. Where am I getting this one? I'm getting it from here. -1, coefficient for I is 1. So that r is 1, -1 squared is 1, 1 squared is 1, that is root 2. It is root 2. So we're going to find the argument of w. The argument of w will be equal to what? Let's use tan alpha. You know that tan alpha equal to b over a. So tan alpha there is, our b is 1 and even a is 1. I told you that we don't consider negatives. We consider negatives when we are looking where it is located on the circle. So tan alpha equal to 1. So alpha is tan inverse of 1. And tan inverse of 1 is pi over 4. Pi divided by what? 4. So when you use a circle, trigonometric circle, we have, we're going to see the quadrant, that is where that w is located in the quadrant. So our a is negative in the x-axis, it is here, but our y is positive axis. You see, it is here in the second quadrant. And we know that in the second quadrant, our angle is pi minus alpha. So our angle will be equal to pi minus pi over 4. So our angle will be 3 pi over 4. So this is the argument of w. So the argument of w, the answer is 3 pi over 4. So after that, we're going to find all cubic roots of w equal to -1 plus I. So we're going to start with z0. Z0 will be equal to the cubic root of root 2 into bracket cos, what is our angle? 3 pi over 4. Then divide by 3 plus 2k, our k is 0, pi over 3 into bracket plus I sine 3 pi over 4 divided by 3 plus 2 into bracket 0 pi over 3. So what am I doing here? I'm just using the formula. I'm just using the formula here. So our r is root 2. Our n is 3. Our n is 3. Cube root of r is root 2. That's cube root of root 2. Then into bracket cos angle. Our angle is 3 pi over 4. Our n is 3. 3 pi over 4 divided by 3 plus 2k. K is 0 pi over 3. So that's what I'm doing. Okay. So now Z0 is, you know, when you have this like root 2, cube root of root 2. This is like 2 power half, power third. So we multiply this one. That is 2 power 1 over 6. And 2 power 1 over 6 is the 6th root of 2. The 6th root of 2. Into bracket. So this 3 is going to cancel with that. We will remain with cos pi over 4. This is 0, because 0 times n now is 0. Plus I sine pi over 4. So that's Z0. Let's go to Z1. This is the first root. Z1, our k, it means that our k is 1. That is 6th root of 2 into bracket cos 3, this angle is not changing, which is pi over 4. Pi over 4 plus 2 into bracket 1 pi over 3. Then plus I sine pi over 4 plus 2 into bracket 1 pi over 3. So Z1, the answer is the 6th root of 2 into bracket. So this is 2 pi over 3. We're going to find the LCM. That's cos. LCM is 12. 12 divided by 4, that's 3. 3 times pi, that's 3 pi. Plus 12 divided by 3, that is 4. 4 times 2, that is 8. 8 plus 3, that is 11. So that is 11 pi. Plus I sine 11 pi divided by 12. So now that is Z1. Let's go to Z2. This is the second root. Z2, our k is 2. To be the 6th root of 2 into bracket cos pi over 4. This pi over 4 is for this one. These 3 cancels with that one, remains pi over 4. It will not change. The side which is changing is this one. So then plus 2 into 2 pi over 3 plus I sine pi over 4, then plus 2 into 2 pi over 3. Okay, now Z2 is the 6th root of 2 into bracket. So cos, so I'm going to find the LCM. LCM is 12. 12 divided by 4, that's 3. 3 times pi, that's 3 pi, plus 12 divided by 3, that is 4. 4 times 4, that is 16. 16 plus 3, that is 19. So it will be 19 pi. Plus I sine 19 pi divided by 12. So that's the answer. You see the cubic roots of -1 plus I. We have Z0, we have Z1, and we have Z2. So that's the answer. I hope there is no any question here. Yeah, thank you. If there's no question, let's go to another number. So now, let's go to number 14. Number 14 is saying compute or calculate integration of sin x, sin 3x dx. Hint, apply complex numbers. You see, we can apply complex numbers finding integrations. So this number, it is number 20b, labeled 2013. So now, how are we going to calculate that integral? Applying what? Complex numbers. So remember, when you have like sin x, sin 3x, you can use Euler's formula and binomial expansion to expand this one. So I don't know if you remember that sin x is e power ix minus e power negative ix over 2I. Do you still remember this? Wow. So let's proceed. So this is the value of sin x. So now what will be the value of sin 3x? Yes, it will be e power 3xi minus e power negative 3xi divided by what? 2I. Good. So now, from there, what is sin x, sin 3x? It will be equal to e power ix minus e power negative ix divided by 2I into bracket e power 3xi minus e power negative 3xi divided by 2I. So 2I times 2I, that is 4I squared, and I squared is negative 1. So the answer is 2I times 2I, that's 4I squared, which is negative 4. It will be negative 1 over 4. You know, when you have like 1 over negative 4, it's the same as negative 1 over 4. Then into bracket, e power ix minus e power negative ix into bracket, e power 3xi minus e power negative 3xi. What we just do, we expand. So the answer is negative 1 over 4. This one times that, we add powers. You know, when you have like a power n times a power m, since they have the same base, we add powers. So e power ix times e power 3xi, we add powers, we get e power 4xi. Then e power ix times e power negative 3xi, that's negative e power negative 2xi, because 1 minus 3, that is negative 2. Then this one times this, that's negative e power 2xi. Then plus e power negative 4xi. I hope we are together there. So now the answer is 1 over 4 into bracket. I just connect like terms together. This one is this. E power 4xi plus e power negative 4xi. So I take a negative outside, minus into bracket e power. It's better to start with the one which has a positive on power. 2xi plus e power negative 2xi. So remember, from when you have 2 cos angle, is the same as e power I angle plus e power negative I angle. So which means that this will be what? It will be 2 cos 4x, and here it will be 2 cos 2x. So which means that sine x sine 3x, the answer is 1 over 4 into bracket 2 cos 4x minus 2 cos 2x. So you can multiply negative a quarter inside the bracket. So the answer is negative 1 over 2 cos 4x plus 1 over 2 cos 2x. So this is the value of sine x, sine 3x. So now instead of integrating this, we're going to integrate this one. So what does it mean? It means that integration of sine x sine 3x dx is the same as integration of negative half cos 4x plus a half cos 2x into bracket dx. So here it is very easy. When you have integration of fx plus g of x into bracket dx, it is the same as integration of fx dx plus integration of g of x dx. We just, because we have two functions, we do integration of each. So that's what we're going to do there. So, and also when you have like integration of a fx dx, sorry, a fx where a is a constant plus b g of x into bracket dx, because the b and a are constants, so it is the same as a integration of fx dx plus b integration of g of x dx. So also if we go to trigonometry, we use the trigonometric circle. This is sine x, this is cos x, this is negative sine x, this is negative cos x. So integration is this, we go on this side, that's integration. We go anti-clockwise. Anti-clockwise means integration. So what does it mean? It means integration of sine is negative cos. Integration of negative cos is negative sine. Integration of negative sine, it is cos. And integration of cos is what? Sine. Simple as that one. So now, if I have integration like sine ax dx, the answer is, because integration of sine is negative, the answer becomes negative 1 over a. This negative 1 over a, it is for this a. Then, because integration of sine is negative cos, that's then cos ax plus constant. That's how we do it. So if I have integration of cos ax dx, the answer is 1 over a, because integration of cos is sine. Then it's sine ax plus constant c. That's how we do it. So which means that, it means that the integration of sine x sine 3x dx, the answer is, I'm going to do integration of this, that's negative half integration of cos 4x dx plus a half integration of cos 2x dx. So now, what is integration of cos? Integration of cos is sine, and I have this constant 4. It will be 1 over 4. 1 over 4 sine 4x. So 1 over 4 times a half, that is 1 over 8. Negative 1 over 8 sine 4x. Sine 4x. So integration of cos 2x, it is 1 over 2. 1 over 2 times 1 over 2, that's 1 over 4 sine 2x plus constant. Let me try to repeat so that you can understand very well. Integration of cos ax, it is 1 over a sin ax, because integration of cos is sine. So it is 1 over a sin ax. So integration of 4x dx, it is 1 over 4. 1 over 4 times this negative half, which is outside, becomes negative 1 over 8 sin 4x plus c. But if we are still doing integration, we just write c after doing all integrations. Then, let's go here. This is 2. This is 2. Integration of cos 2x, it is 1 over 2 sin 2x. 1 over 2 sin 2x, but here we have a half. A half times a half, that is a quarter. A quarter sin 2x plus c. So which means that this is the answer of this integral. It is negative 1 over 4, sorry, negative 1 over 8 sin 4x plus 1 over 4 sin 2x plus c. I hope you don't have any question. Yeah, this is the integration, but I wanted to show you how we apply complex numbers when we are doing integration, which means that we need to take care about complex numbers so that it will help us to do calculations about integration. So let's go to another number.